Miss Bisagno is 12 feet away from the boat and holding onto a rope for dear life. One of her students is on the deck of the ship and is pulling in a rope at 0.5 feet per minute. What is the rate of change in the angle formed from Miss Bisagno to the bottom of the boat? So we've got a lot here going on, but we are going to go ahead and draw a picture first so that we have an idea of how these things relate to one another. So we've got a boat. I'm just going to kind of draw like this is the boat. It's not great. Okay, there's a boat. Here's Miss Bisagno. She is like holding on to a rope for dear life. One of her students is on a deck of a boat. So here's my student over here. They're holding on to a rope. Assume that rope is really tight, and I'm in the water holding on. Okay, now at this moment in time, I am 12 feet away from the boat, but the student is pulling in the rope. So as the rope gets shorter, I'm being pulled closer to the edge of the boat. That means that this distance, I'll call this X, that distance X is changing as I get closer and closer. The deck of the ship is 16 feet high. Now that is not changing, so I am allowed to mark that as 16 because the boat, we have to assume, is going to stay at 16 feet. And then we know that the rope is being pulled in at 0.5 feet per minute. So that, I'll call that Z, I guess. So Z is changing because the rope is being pulled in. And we are finding the rate of change in the angle formed from Miss Bisagno to the bottom of the boat. So we are looking at a rate of change of an angle here. So I need to also label my angle. And I'm going to go ahead and label that theta. So we know that the rope is being pulled in. So dz dt is negative 0.5 feet per minute. And that is negative because the distance is decreasing. The rope is not being let out. The rope is being pulled in. So that distance is decreasing. So it's a negative rate. And we are looking for what is the rate of change of the angle. So d theta dt is what I'm questioning, or is what I'm trying to figure out. So first thing I need to figure out is what is I'm sorry, I should have put when x is equal to 12, because at this moment in time, I know I am 12 feet away from the base of the boat. Okay, so I need to set up a basic equation. So in order to relate theta to x and z, or if I want to relate theta to 16 and z, I actually have a few different options, because with SOHCAHTOA, I can use sine, I can use cosine, I can use tangent. You can actually do whatever you want. You can use sine, you can use cosine, you can do tangent. I'm going to go ahead and use sine. And that's because I know dz dt. So I definitely want to use my z. So that gives me either I want to use cosine or I want to use sine, because I'm given dz dt. So I definitely want to have a z in there. And I kind of want to use the 16 because that's not changing. The derivative of 16 will just be 0. So that kind of makes things easier for me. So I'm going to go ahead and use sine. So sine of theta, SOHCAHTOA, so sine is opposite over hypotenuse. And then when I take the derivative of sine theta is cosine theta times, don't forget to take the derivative of the variable with respect to time, d theta dt. And the derivative of 16, that's 16z to the negative 1, right? So that's negative 16z to the negative 2 times dz dt. We have to take the derivative with respect to time. So that's why I wanted to use sine, was because it just gave me 16 as a constant. If I had used cosine, that would have been x over z. I would have had to use the quotient rule, because that would have been two variables. And the derivative of a variable divided by a variable, you have to use a quotient rule, the quotient rule there. So with this, I didn't have to use the quotient rule. And then let's plug in what we know. Cosine theta, I don't know right this minute, so I'm going to hold off on that. I obviously don't know what d theta dt is. That's what I'm trying to solve. I know that, let's see, do I know what z is? I do not know what z is right this second, but I can figure that out. And dz dt is negative 0.5. Okay, so I have a few unknowns. Cosine is an unknown, and z is also an unknown. So let's look at things we can do to solve. So I know this moment in time is when x is equal to 12. So that gives me, again, at this moment in time, 12, 16. I can figure out what z is by using the Pythagorean theorem. So 16 squared plus 12 squared is equal to z squared. Is this a 3, 4, 5? 16 is 4 times 4. 12 is 4 times 3. It is a 3, 4, 5. So z is 4 times 5, which is 20. So z is equal to 20 feet. And then cosine, so SOHCAHTOA, cosine is adjacent over hypotenuse. So at this moment in time, the adjacent side is 12, and the hypotenuse is 20. So at this moment in time, I can figure out what cosine is, which is 3 over 5. So I can figure out both of these by using Pythagorean theorem and SOHCAHTOA, and then I can go back and plug them in. So cosine was 3/5 d theta dt. Notice that I didn't have to find what theta is. I just had to find what cosine of theta is using SOHCAHTOA. So don't overcomplicate things, especially because you're not given a calculator for a lot of these problems. I haven't used a calculator once. Don't overcomplicate it, just use SOHCAHTOA a lot for these angle type of problems. Z was 20 squared times negative 1/2. So that is 3/5 times d theta dt, which is, let's see, that's 8. That's going to be a positive, so 8 over 20 times 20. Again, I'm not using a calculator, so times 5/3 theta dt is equal to 8 times 5 is 40. 40 divided by 20 is 2. 2 over 20 is 1/10. So I get 1/10 times 1/3, which is 1 over 30. Now, d theta dt is going to be the units of an angle over, in this case, minutes, right? Okay, so what are my units? Are they radians or degrees? So, as I've said since the first day of school, you are never, ever, ever in degrees in this class unless we're talking about temperature. So d theta dt is equal to 1 over 30 radians per minute. Fun fact, I don't know if we've talked about this, the derivative of sine is cosine if you are in radians. If you are in degrees, the derivative of sine is not cosine. If you are in degrees, your derivatives for trig that you know do not work. So you have to be in radians mode, which means you have to think about things in terms of radians, which means your answer for a rate of change of an angle will be in radians, because you are not finding the derivative in degrees. You are finding the derivative in radians. So the angle is changing at a rate of 1 over 30 radians per minute.